we're changing a little bit into exospheres. I want to point out Benjamin Sprague was an intern last summer from the U.S. Naval Academy. He did a lot of this work finding the rates of outgassing in various things. So what we looked at was the sources of anthropogenic atmospheres on the moon from various things that might be on the moon. We did not look at the Starship plume deposit that was done by Parvati, but we did look at outgassing from the Starship. It's just sitting on the moon. We looked at airlocks, backpacks, mining. We only looked at mining of water because we couldn't find a lot of information about mining for minerals. It's probably proprietary at this point. Trash, we looked at trash to gas. We did not look at sequestration of the gas, which is proposed in the future. And we looked at the rover. So for all of these various sources, water is the most prevalent outgas species. The airlocks outgas oxygen and nitrogen. The trash outgasses methane, carbon dioxide, and carbon monoxide for the most part. Mining of ice outgasses water, but oxygen is formed from electrolysis of the water. Mining for metals may outgas other volatiles existing in the regolith, and we did not look at that. And the plume species obviously depend on the propellant type. We did look at that in the paper. Rovers outgas water, hydrocarbons, and some of them outgas fluorine if you have things like gray coat, which is probably not used anymore. So the assumptions of the model are just the one balanced model. It's the atoms are ejected, they immediately adsorb to the surface. And so this results in a lower limit of the exosphere. The measured column abundances were not found. In other words, the native gas for water is a little bit uncertain, nitrogen, oxygen, or carbon monoxide. And estimates for mining were only found for mining ice, so we didn't consider mining for metals. And we modeled the static Starship and not the fluke. So these are our sources. The backpack is assumed to be water cooled. The temporary local surface number density from the astronauts' backpacks exceeds the ambient value by 2 to 3 orders of magnitude in the 100-kilometer region around the backpack. But within 1.5 meters of the backpack, there can be a collisional atmosphere which follows the astronaut, but obviously doesn't last. The water molecules, obviously, they're adsorbed, but they can dissociate or react. And we didn't consider what happens after that, which would be the follow-on study. So the rover is not a significant source of ambient, of the anthropogenic exosphere. The estimated surface density of the rover outgas water represents less than 0.1% increase over the local water density. So it's not a huge source. But airlocks, we considered 4 different airlocks. People have looked at different airlock designs, especially for Mars. And we assume that 90% of the air in the airlock can be reclaimed. This is what people are trying to do. And the mix of oxygen and nitrogen differs depending on the pressure in the airlock. So you have to increase the oxygen as the pressure decreases to maintain life support. So that's the reason why the mix changes. So the goal of the Artemis program is to reduce the gas loss for an order of magnitude, but we used the gas as it currently is done. So the column abundance varies from about 10 to the 8 to 10 to the 10 per square centimeter. which is significant. And the nitrogen, but we don't know. But the oxygen column abundance is not sure what I'm trying to say here. It's approximately equal to the native nitrogen oxygen from Feldman and Morrison. Okay, so the starship plume and mining produce significant increase in the superficial and exosphere water. The starship plume obviously is the most significant taken from Parvati's work, but even if the starship is just sitting there, you get 3 orders of magnitude increase in the local exosphere. For mining, you get 2 to 3 orders of magnitude increase. This is obviously very poorly constrained because we don't really know a lot about how they're going to do the mining and so forth. And we only considered mining twice. So the near source exospheres are obviously a lot denser than farther source. And within 100 meters of the source, it can significantly increase the exosphere. And you get a collisional exosphere very close to the source, but obviously if your source is moving like an astronaut, it's very short-lived. And of course, the colder the source is, the denser the exosphere is near the source. So what about trash? We assumed a colder source than if the trash is being incinerated, but I assume that it's going to cool off. So that there was some question about that, but this is the temperature that we assumed. So obviously, the more people you have, the more exosphere you're going to get. That's basically what I'm saying here. So in conclusion, human activity on the moon will produce anthropogenic exospheres. They're short-lived unless your source is permanent. Obviously, if you have a habitat and it's sitting there, it's going to continue to outgas.
2 minutes.
Well, actually, that's the end.
Perfect.
We were, Ben Sprague was a summer intern from the Naval Academy, and I was funded by Survey. So thank you.